Hello everyone, welcome to this video. In the previous video, we have seen Ohm's law, Kirchhoff voltage law and Kirchhoff current law. In this video, let us see the series circuits, parallel circuits and series parallel circuits. Let us get into the series circuits. What is a series circuit? Series circuit is a circuit where the elements are connected in series. You can see in this diagram, R1, R2, R3 are the resistors. They are connected in series. One after the other, if we are connecting, we say it is a series circuit. And if the series resistance is connected like this, we have R1, R2, R3, the total resistance can be written as R1 plus R2 plus R3. And you might have known that the current flowing through this circuit because of this voltage source is in this direction. The direction of current is indicated here, it is I. The current flow will be in this direction and all the elements will be carrying the current same. Means the current flowing through the circuit R1, R2, R3 is same. But the voltages across R1, R2, R3 are different. Voltage across R1 is V1, R2 voltage is V2 and across R3 we will be getting V3. Here remember, voltages are different, currents are same. If n number of these resistors are connected in series, then what is the expression? RT, the equivalent resistance or the total resistance will be equal to R1 plus R2 plus R3 so on up to the nth resistor. You can observe here I have written the equivalent resistance of these three. We can add these three resistances are in series and we can write the equivalent resistance as R equal. And the direction of current flow will be same. And if we add V1, V2, V3, that will be equal to the total voltage. Here also the voltage across R equivalent will be same as V1 plus V2 plus V3. Now the voltage is V1 plus V2 plus V3 and individual voltages are V1 is equal to I1 R1, V2 is equal to I2 R2 and V3 is equal to I3 R3. And if we write the expression in terms of resistance equivalent, it is I into R equivalent. And R equivalent is R1 plus R2 plus R3. Now, what are all the characteristics of this series circuit we have understood? The same current flows through the circuit, means in each resistance, and the supply voltage is V, which is sum of the individual voltage drops at each resistances, that is V1 plus V2 plus V3 in our circuit. The equivalent resistance is equal to the sum of individual resistances. Similarly, the equivalent resistance is largest of all the individual resistance. If you take the equivalent resistance R, obviously it is R1 plus R2 plus R3. That's why R is, if we compare with R1, R2, R3 like that, it is a higher value. Let us take an example and let us solve for current as well as voltages. In this circuit, they have given the supply voltage as V is equal to 9 volts and three resistances are there, that is R1, R2, R3. They are connected in series. And the voltages across these resistors are V1, V2, V3. And we know that then series 3 resistors are connected, the current flow will be I. This I is same in all the three resistances. The equivalent resistance if we write for this, that is RT, that is the addition of 1K plus 2K plus 6K, so that is 9K. This is the total resistance of the circuit. So now we need to calculate the current as well as voltage across each resistor. So to calculate current and voltage, first we need to calculate what is the total current flowing through the circuit. The total current I is equal to V divided by R. What is V? V is the supply voltage they have given, it is 9 volts. And R, the equivalent resistance of all these three, that is RT, which is 9K. So 9 volts divided by 9K, that gives 1 milliamps. Why? Because here it is 9 kilo will be represented as 10 raised to 3. It becomes 1 into 10 raised to minus 3. That is milliamps. The current flowing through the circuit is 1 milliamps now. Now we need to find out what is V1 and what is V2 and what is V3 individually. We know that Ohm's law, V is equal to I into R. The same concept is applied here to find out V1. It is the current flowing through the resistor and the resistance offered by that element. So V1 can be written as I into R1. Similarly, V2 can be written as I into R2. V3 can be written as I into R3. So current is same here. You can observe the current can be taken same for all the three, and voltages are different. 1 kilo ohm, 2 kilo ohm, 6 kilo ohm. So accordingly we are going to get voltage V1 is 1 volt, voltage V2 is 2 volts, voltage V3 at resistance R3 is 6 volts. Like this we can solve the problem when the resistances are connected in series, and we can find out what is the current and what are all the individual voltage drops across the resistors. Then we have one more problem here. The three resistances, that is 100 ohm, 200 ohm and 300 ohm, are connected in series to a 250 volt supply. Determine the current in the circuit and power dissipated in each resistor. Here they are asked to calculate the power dissipation also in each resistor, and also we need to determine the current. So the circuit, if we write, if they have not given the circuit, you are supposed to write the circuit. So 10 ohm, 200 ohm, 300 ohm are given in the question. So I have connected in series and I have named it as R1, R2, R3. And they have given it is connected to 250 volt supply. I have connected a battery of 250 volts DC. And we know that current through this circuit, since these three are connected in series, it is same. That is the total current I. Now I need to calculate the equivalent resistance first. Equivalent resistance is R1 plus R2 plus R3 since they are in series. So the total resistance is 600 ohm. Once we get the voltage as well as the total resistance of the circuit, we can calculate current. So current I is equal to V by R. V is 250 volts and the resistance equivalent is 600 ohm. 250 by 600 gives 0.417 amps. This is the amount of current flowing through the circuit. And then we need to calculate power. We know that power is equal to voltage into current. Power dissipated by individual resistor will be the voltage across the resistor and the current flowing through that. And we know that the voltage across the resistor R1 is V1 and voltage across the resistor R2 is V2 and voltage across R3 is V3. P is equal to V into I, as V is I into R. So I am replacing that V by I into R. In the expression we will be having I again. So the another expression for power is I square into R. You can directly write it as I square into R, and we know the current and also we know the resistances. So we can calculate the each power dissipations at each resistors. So I square R1, it gives 17.36 watts. I square R2 gives 34.72 watts and I square R3 gives 52 watts. Then we have parallel circuits. The same resistances which are connected in parallel, what happens? That we need to understand. Here is the circuit showing three resistances connected in parallel. We can connect n number of resistances also, that's why it is shown as dotted line here. Once we connect the parallel circuits like this, what happens? The total current in the circuit is I because of the supply voltage V. It is divided as the branch currents. Here we say these three are the branches. So the branch current will be named as I1, which is flowing through R1, and I2, which is flowing through R2, IN, which is flowing through RN. If we add all the currents, it will be equal to I. So you recall the Kirchhoff current law. The total current I is equal to the branch currents at the junction, right? Suppose if we take this as junction, here is one branch, this is another branch, this is the another branch. The total current I will be equal to I1 plus I2 plus IN, right? And the voltage, if you observe the voltage V, we are measuring the voltage across the resistor here. Similarly R2 voltage here and RN voltage here. These 3 points are same, right? So the voltage across the parallel elements will be same. So if you measure the voltage across R1, if you measure the voltage across R2 and if you measure the voltage across RN, it is same. And currents are different and voltages are same. We can represent that with I into R combinations. And if we measure the current, the total current I1 plus I2 plus I3, that can be written as V by R1 plus V by R2 plus V by R3 also. Or the equivalent resistance is calculated. How the equivalent resistance is calculated here? The equivalent resistance is 1 divided by R equivalent will be equal to 1 by R1 plus 1 by R2. It is not R equivalent is equal to 1 by R1 plus R2. It is 1 divided by R equivalent. Okay, remember it is 1 divided by R equivalent is equal to 1 by R1 plus 1 by R2 if the two resistors are connected in parallel. So that equivalent resistance is taken here and the total current is I. So the total voltage can be measured using this expression. And this is what the equivalent resistance if they are connected in parallel, that is 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This is the voltage, so that we can calculate the current also, total current. So with this knowledge we can also write the equivalent like this. So with this knowledge, let us see what are all the characteristics of the parallel circuit. The potential difference gets across all the resistances in parallel, means the potential difference V is same across all the resistances connected in parallel. And total currents get divided. Current will be divided into number of paths. And if we write the current I is equal to I1 plus I2 plus I3 up to the nth resistor. And reciprocal of the equivalent resistance of a parallel circuit is equal to sum of the reciprocals of individual resistances. That's why the expression is 1 divided by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. And again equivalent resistance if we take, that is smallest of all the resistances. In series it is bigger than all the resistances, but here in the equivalent resistance of a parallel circuit, the equivalent resistance value is less than the individual resistance what we have in the circuit. And the equivalent conductance is the arithmetic addition of all the individual conductance. That is again related to this current. The total current will be equal to the branch currents. Similarly here the equivalent conductance if we take, that is I, the algebraic sum of each and every conductance in individual elements. Let us see the problem. Here three resistances 750 ohm, 600 ohm and 200 ohm are connected in parallel, and we know that the currents are going to be divided. That's why let us find out the currents first. Again in the question also they have asked to determine the voltage applied and the current in the each branch. So let us try to write the expression for current. Current I1 is equal to V divided by 750 ohms, I2 is equal to V divided by 600 ohms, I3 is equal to V divided by 200 ohms. But we need to find out this V, right? So the total current I is equal to I1 plus I2 plus I3. This is equal to the addition of currents, individual currents, that is V by R1, V by R2 plus V by R3. And they have given the total current flowing in the circuit. The total current is 1 amperes. You can observe here this is 1 ampere current. So in the left hand side we will be having I, we can replace that by 1. 1 is equal to, if we take V common out of these three expressions, V into 1 by 750 plus 1 by 600 plus 1 by 200, and if we calculate this and we are going to get the expression I is equal to V into this much, and if we rearrange this expression for V, it is 1 divided by 0.008. It gives 125 volts. This voltage across the resistor will be 125 volts. Now we have calculated this V. And current through the each branch if you calculate, now we got this V. So if we put V here, we can calculate I1 and we can calculate I2, we can calculate I3. By using these expressions, if we calculate I1 is 0.166 and I2 is 0.208 and I3 is 0.625. So after getting these three currents, you can cross verify that after adding these three, if you add I1, I2, I3, the total current should be equal to 1 amps. Okay. This is how the parallel circuits can be analyzed. Next, series parallel circuits. In series parallel circuits, we will be having some components connected in series. You can observe here these two are connected in series, and the equivalent of these two if we write, this will be connected in parallel. So by to analyze these circuits, what we are supposed to do, first we need to write the equivalent of these two. We need to simplify this complex circuit into a simplest form by writing the equivalent circuit. So how to write? First let us consider this resistor and this resistor. We know that these two are connected in series. We can add up. The two resistances are added and the equivalent resistance we got at this place will be 12 ohm. So we can replace these two by 12 ohm. So now I have put 12 ohm resistor here by naming it as RA. And then now you can take this and this into account. These two are connected in parallel. Okay. By taking this and this, you can't say it is series. Why? Because there is a parallel branch here. So these two are connected in parallel. First we need to get the equivalent of these two. By taking the equivalent of these two, that is 1 divided by 12 plus 1 divided by 12 is equal to 1 divided by R equivalent. For this it gives 6 ohms. R equivalent is 6 ohms out of these two. Now replace these two by 6 ohm resistor. Now the simplified circuit becomes R1 and R equivalent in series. Now the two resistances are in series, we can add those two and we can replace that by a single resistor of 12 ohm. Now the 12 volt is the voltage which we have given for this circuit. We have reduced the complex circuit into the simplest one by taking the equivalent of series and parallel circuits. Now we can calculate the current here. The current flowing through this resistor is voltage divided by the resistance, that is 12 volts divided by 12 ohm, that is 1 amperes. 1 ampere of current is flowing through the circuit. Like this we can solve the series and parallel circuits also to arrive with the total current or the voltage flowing through the circuit.